In this video, I'll teach you everything you need to know about TypeScript as fast as possible. So let's start with what TypeScript is. Now, TypeScript is a superset of JavaScript, which means it extends the capabilities of JavaScript by adding optional static types. Developed and maintained by Microsoft, it was first released in 2012. Now, TypeScript helps you write more robust and maintainable code thanks to its type checking features. It catches potential errors during development rather than at runtime, which saves you tons of time and effort. Now, don't worry about browser compatibility, as TypeScript compiles down to plain JavaScript, ensuring that your code runs smoothly across different platforms. TypeScript is well suited for large-scale applications or when working with teams, as it enhances the code readability and maintainability. To sum it up, TypeScript brings the benefits of static typing to JavaScript, making it a powerful ally for developing modern web applications. Now, let's dive into setting up TypeScript and writing our first TypeScript code. Alright, so I'm going to get into setting up and installing TypeScript, but I did want to mention that if you're looking to get better at programming, I do have a programming course called programmingexpert.io that you guys can check out from the link in the description. And if you're at all interested in blockchain and Web3 technology and becoming a developer in that space, then check out my other course, Blockchain Expert, again from the link in the description. Now, let's set up TypeScript. So the first thing we need to do to set this up is download Node.js. I imagine many of you already have this installed. If you don't, go to the Node.js website and install Node.js. Once you have that installed, we're going to open up some kind of directory that we'll do this project in, and we're going to install TypeScript globally just so that we have access to the TypeScript command from any directory. So I'm going to type npm install -g and then TypeScript. This only works when you have Node.js installed. Now this will install TypeScript globally for us. I'll be back once it is finished. All right, so that command finished pretty quickly. If we want to check if this is working, we can type the command tsc-v, and that should give us the version of TypeScript that we're using. If you see some output here, then that means that installation was successful. Now that we've done that, I'm going to create a new directory here, or a new npm package, and then we're going to set up TypeScript by creating a tsconfig.json file. So I'm going to type npm init-y. This is going to create a package.json file for me in this directory. So now I have an npm project, and now I'm going to create a new file. This is tsconfig.json. This is where we're going to put configuration for TypeScript. So I'm just going to paste in here a fairly basic configuration, and then we'll go through the options. So you can see that we have a JSON object, we have our compiler options, and then we're specifying the target is ES5, the type of module is CommonJS, we're using strict mode. The output directory is dist. Now, this is the directory that our compiled TypeScript code will go inside of. So essentially, it's going to transpile our TypeScript code into JavaScript, and that will then live in the dist folder. And then I have skip libcheck, which is just going to skip checking any of our node modules or libraries so that we don't have to actually go through the process of doing all the type checking on them. You can disable this if you want, but I usually just enable it. And then I have include, and this is specifying what files I want to include in my kind of TypeScript project here. So in this case, I'm including anything inside of src. This here means that it can be any subdirectory of src. And then I'm specifying that it needs to end in .ts. So this is a basic configuration for TypeScript. Now notice here, if I hover over this, that I'm getting an error. And it's saying no inputs were found in the config file, and that's because we have not created this src directory. So what I'm going to do is create a directory here called src. This is where TypeScript expects that our files are going to live. And then I'm going to create a file here called index.ts, and note that ts is the TypeScript extension, and then you get the little ts logo here if you're inside of Visual Studio Code. All right, so now inside of our TS file, I'm just going to write some very basic TypeScript and then show you how the transpiling or compiling, whatever you want to refer to it as, works. So I'm going to say let x number equal 3. Okay, so this is some basic TypeScript code where I'm specifying the type of this variable. And now I want to show you that if I want to compile this code into JavaScript, all I need to do is run from the directory where my tsconfig file is the tsc command. This is kind of the alias for building. So if I do this and hit enter, it's going to build our project into this dist folder. And you can see that we have our index.js, where we have the same thing that we had here, except now kind of converted into regular JavaScript where we don't have this type annotation. All right, so now that we've set up TypeScript, let's have a look at some of the types that you can use within TypeScript. So let's create some variables. Let's say let x : And we can start with a number equal 3, just like we had before. Now note here that this is the way that you annotate types. You put a colon and then you specify the type that this variable is going to be. In this case, I've made it equal to 3. I also could just define the variable like this, and then I could assign it later on, so like x equals 2. Now, if I try to do something like x equals hello, you're going to see that I get an error here. It's telling me the type string is not assignable to type number. There you go. You've already seen a massive benefit of TypeScript. In regular JavaScript, you wouldn't get this type of error because there would be nothing specifying that x needs to be a number. So very helpful for larger development projects. Regardless, that's one of the most common types. Another type that you can use here is a string, fairly straightforward. You can also use a Boolean value, so that's going to be true or false, and you can use the any value. Now, the any value is essentially skipping creating a type for a variable or for whatever it is that you're attempting to type. This means that you can have anything inside of the x variable. So really, it's kind of saying no type. So you put any. I don't know if that makes sense or not, but I can do something like x equals 4, x equals hello, and TypeScript will not get mad at me because it has the type of any. Now, one thing to note here is that you don't need to manually specify the types for your variables. They can actually be implied. That's the same with your functions and with really anything else in TypeScript. So if I do something like const hello is equal to hello world, and then I go down here and I try to say something like hello minus 8, you're going to see that I get an error, and that's because it knows that the type of hello is a string, right? So the left-hand side of an arithmetic operation must be of type any, number, or big int, and since this is not of that type, it's not going to work. And if I hover over this, it actually doesn't tell me that it's type string, but it does know implicitly that it is the type string because that's what I assigned to this variable. All right, so continuing, we have the type of unknown. So I could do something like let y unknown like that. Now, the difference with unknown and any is that if you attempt to use the unknown type, you're going to have to typecast this or convert it into a different type to be able to use it properly, whereas with any, it essentially kind of skips doing any of the type checking. We'll have a look at this later on, but understand that any and unknown are different. Any is just going to kind of allow you to skip all of the type checking, whereas unknown is going to now force you to do all kinds of typecasting and checking to be able to use this variable properly. All right, so next we have the type of void. Now, void is used when you want to specify that a function is not going to return any value. So let's say we create a standard function here. I'm going to say function x, and then we'll just put our parentheses here. Now, if I wanted to annotate this function, which I don't need to do, but I can do, I can put a colon here and then put void, and this now indicates that this function is not returning any type of value. Now, same thing if I wanted to do function parameters here, I could do something like, let's say num1, and this is a number, and num2, this is a number as well. Now I've kind of typed this function, and I know that I'm accepting 2 numbers for my parameters, and I am returning nothing. Okay, so that is the void type. You obviously could put a different type here, like number, and then that would mean that you're going to return a number. However, I have to actually return a number, otherwise this is going to get mad at me. So I'm returning num1 plus num2, and now I don't get any errors. All right, the next type that we have is null. So of course I can do something like var val null is equal to null. That is perfectly fine. That is the null type. Continuing, we have the undefined type. So if I say val undefined, then obviously I can make this equal to an undefined value. Sometimes that's useful, and we'll look at some more complicated types where you might use undefined. All right, next we have the array type. So I can, of course, do something like var nums, and then say number like this, and then put my array symbol here, or my 2 brackets, then make this equal to an array of different numbers. That is a valid type. We can then have a 2-dimensional array if we wanted to do that. So now we're going to have an array inside of an array for this to be a valid type. Now, beyond array, we actually have another type known as a tuple or a tuple, however you want to refer to it as. So let's say I have kind of an interesting object here. Let's just call this obj, where what I actually want to have is a string and a number. So what I can do is specify the type like this. This is now a tuple type, and that means that I have to have an array that has exactly 2 values, one of which is string and one of which is a number. So I'll say hello and 2 like that, and now this is valid. That's how you specify a tuple. Continuing, we have the object type. So I can put object like this, and now it's expecting that we have some kind of object here. There you go. Those are the core types in TypeScript. Now, let's have a look at how we can create custom types, which are probably the more useful things that you're going to be using quite a bit in TypeScript, and some more examples of just typing our objects and using these different TypeScript features. All right, so moving on now to custom types, which is probably why most of you are watching this video. In TypeScript, if you want to create a custom type, use the type keyword, and then you set the name for the type. So I'll do a type like animal. Inside of here, I now specify all of the properties that I want something of this type to have. So I can do something like name, and this can be a string. Maybe we have age. This is going to be a number. Maybe we have the colors of this animal, and this will be a string array. And then maybe we have some optional fields, like let's say legs, and this can be a number. Now notice I'm using this question mark here to specify that this is an optional value, so we might have it or we might not have it, and that means implicitly TypeScript is going to say that legs is a number or an undefined type, because we might not have this property, so it could be undefined, or if we do have it, it's going to be a number, and I'll show you how we handle that in just a minute. Okay, so this is a very basic type. Now, of course, we can continue and create different types, and typically it is a good idea to put all of your types inside of a types file. So you might have a types.ts file. Inside of here, you might say something like export type, call this maybe type 1, and then you would specify the type, and then you would import this in the files that you needed it. Obviously, that can get a bit messy if you have tons of different types. You might want to separate them by subdirectory or where they're being used, but just something to note that a lot of people will kind of dump all of their types inside of one file like types.ts. All right, so let me just create an animal here. I'm going to say const dog is equal to, and then I'm going to say name is Tim. I will say the age is 10, and the colors are brown and black. Okay, so now I've created something that does actually adhere to this animal type, but you'll notice that if I hover over it, it's not specifying that this is type animal, and that's because I've not annotated it as an animal. So I don't need to do that to be able to use this like an animal object, but sometimes it's going to be helpful for you to manually annotate this, so that you know that it's of this type. So I'm saying dog, now it's telling me it's of type animal. So that's one way to do that. Another way to do this is to type as and then animal. This is essentially a type cast or conversion, where what we're doing is we're taking this type and we're telling TypeScript to treat it as the animal type. So now if I hover over this, same thing, we're able to implicitly kind of define that this is of type animal. Now let's just remove this just so I can show you that we can use this like an animal. So I'm going to create a function here. Let's say const print animal. We'll make this equal to an arrow function, and we'll just take in an animal that is of type animal. And then what I can do is say console.log, and I will print the animal.name and the animal.age. Now you'll notice that if I pass this to print animal, this is fine. I don't get any type errors here, and that's because, again, this can be treated as the animal type because it has the correct fields. If I were to comment out one of these fields here and get rid of the name, then notice that I get an error because it says argument of type age colors is not assignable to parameter of animal. Property name is missing in this type. And same thing, if I tried to now annotate this as an animal, we're still going to get this error because we don't have name defined, which is a property that we need. However, even though we are not including legs, everything is fine. Now, let me quickly show you what happens if we try to access this legs property. So if I go here and I say animal.legs, it's fine. And the reason why we can do this in the print statement is because it's either going to print undefined if it's not defined, or the number of legs. But if I tried to do something like const x is equal to animal.legs -5, notice I'm going to get an error here because this could be an undefined value. So if this is the case, what you can do, and I don't recommend this, but you can do this, is you can use the bang operator. And what this will do is make it so that TypeScript treats this as if it's a defined value. Now, the issue with doing this is that you can sometimes have an undefined value that you attempt to use a bang on, and that means we're now going to have undefined -5. And when we have that, that's going to raise an exception for us at runtime, which we don't want to occur. So instead of using this bang, what I'll typically do is something like this. I'm going to have animal question mark animal.legs colon, and then probably something like 0. Now, what this is saying is if animal.legs is defined, so pretty much if it's not undefined, right? That's kind of what I'm checking here. If we want it to be more explicit, we could say does not equal undefined, then we will use animal.legs. Otherwise, we will use 0. So this is a safe way for us to access that property. Just wanted to quickly show you that. Okay, so now that we've kind of looked at that, I just want to show you an example with some more complicated types and how we can kind of nest types together. So let's say that we have maybe something like a farm type, okay? On this farm, we're probably going to have animals, which means we'll likely want to use our existing animal type. So obviously we can do that. We can specify animal and say that we're going to have an array of different animals. Now, maybe we actually want to have, say, animal names to objects. Well, what we could do is use some kind of mapping type, which again is a more complicated type in TypeScript that I'll show you. So oftentimes you want to have an object where you have some kind of key that is a specific value that maps to a value. Well, the way that you do that is you define an object here. Inside of square brackets, you specify the key. So I'm going to have name, which is a string, and then this is going to map to the type of animal. Okay, so I've said I have an object. Inside of the object, I have keys, which are the name of type string, and then the value associated with them is an animal. So that's how you would do this using objects. Of course, you can get more complicated here, have nested objects, nested types, all that kind of stuff. But these are kind of the common, ways that you're probably going to define different types. All right, so continuing here, I want to show you a few operators you can use to join types together or to essentially allow for different types. So let's say that for some reason, maybe we want colors to be equal to a string array or a string. We have the ability to do that in TypeScript by using this operator right here, which is the pipe. So what I can do now is specify that I have colors, and that can be the type of a string array or just a single string. I could then, of course, continue and add different types here as well that this could be equal to. Now, obviously, you don't want to go crazy because it makes it a little bit difficult when you're checking these different values and trying to use them, but this can be useful if you want to have, say, 2 different types or an option for the types. Now, continuing, let's say that we have another type, and this type is going to have everything that animal has plus a few other values. Well, what I might do is the following. Let's say we have a type of, I don't even know what would make sense here, maybe like a monkey. And let's say that on our monkey, we want everything from animal, but we also want to have a diet. And let's just say the diet is a string, I don't know, some description of what they eat. Well, rather than me writing all of this again inside of monkey, what I will do is have this type and then put an and symbol and then put animal. Now, what this will do is an intersection of the 2 different types, which means I must have all of the properties on animal and on this original monkey type for it to be type monkey, okay? Hopefully that makes a bit of sense, but now if I look at my type monkey, it is diet plus all of the different values from animal. So if I wanted to make a monkey, I said const m monkey like this. Now I need to specify all of those types. So I'll have my diet, which we'll just say is food, even though I know that's not very specific. And then note here, it's giving me an error because I need to specify name, age, colors, etc. All right, so just to wrap this up, I'm just going to show you a small edge case here when it comes to annotating types. So let's say that we're defining a set, for example, in JavaScript. So const s is equal to new set, not setting, new set like that. And actually, that reminds me, I'm just going to go to tsconfig here, and I'm going to change ES5 to ES6 because that's what I need if I want to use a set. Okay, so now set is working fine. Notice, though, if I hover over set, it says new, unknown, and then specifies the set type. And it has iterable, whatever, etc. Now, that's because right now, TypeScript doesn't know what the type of our set is going to be because we haven't put any values inside of it. So what we can do, if we wanted to ignore that, is we could put any, and now we're not going to have that unknown type, and we can just have anything inside of our set. However, what you're probably going to want to do is specify what the actual type will be. So you can say new set, and then specify that this is a number inside of these angle brackets. And now if I hover over this, we know that we have a set that contains numbers. We could also do this, where we specify the type here. So we're going to say new set number like that. And now this is the same thing. So whatever way you want to do it is fine. Typically, I let it implicitly kind of pick up what the type is by just specifying it here, but you can obviously annotate it on the variable itself. All right, so now that we've discussed custom types, I want to talk to you about interfaces and the advantage of using them over types in specific scenarios. Keep in mind, this will be a high-level overview. There is a lot of differences between interfaces and types in TypeScript. I'm just going to scratch the surface here and give you an introduction. All right, so let's have a look at this example here where we have both a type fish and a type dog. Now this is fine. We have two types. They share one property here, which is the name. And then we have a function that we want to be able to use on both our dog and our fish. Now in TypeScript, we know that we can simply just put a pipe operator here and specify all of the different types that we can accept as an argument to this function. Now in the situation here where we have two different types, we know that we can access the shared property of these types because, well, they both have the same property, right? So both dog and fish have name, which means it doesn't matter what you pass here, we're able to access name. Okay, so that's fine. We can print out their name. Now, the issue arises here when we have all of a sudden like 20 types, 30 types, 40 types that we potentially want to accept inside of this function that we all know are going to have this name property. Well, I don't want to constantly keep adding, the other type, the other type, the other type, because really all I care about is that these types have the property name on them. So rather than creating a new type and using that here, I'm going to specify something known as an interface. So I'm going to say interface animal like this, and then we're going to specify that name is a required property. Now what I will do is I will switch the type annotation from fish or dog to be animal. Now, what that allows me to do is to pass any type of object, regardless of its type, that implements the animal interface, which means it simply needs to have this name property on it. That allows me now to access name. Now, I could access any other property that is on this interface, and this makes it very easy and kind of more reusable for me because I don't need to constantly keep adding types to the type annotation. And if for some reason anything changed in my animal interface, then it automatically changes here, rather than me maybe mistakenly removing a name from my dog or my fish and then breaking all of this code. Hopefully that makes a tiny bit of sense, but typically you're using an interface when you want to view a specific object or type through the lens of another type. So the interface is not going to be the type of any individual variable that you define. I'm not going to say something like const x animal is equal to, and then specify a name. I can do that. It's valid for me to do that, but instead I'm most likely going to have a fish where then I implement a function like swim. So we say swim does this, and then I will pass my fish and view it as if it's an animal inside of this function. I know that might be a little bit confusing. Again, there's a lot of overlap between how you can use interfaces and types inside of TypeScript. Typically, though, again, you're using an interface when you want to ensure that whatever's being passed to a specific function or used in a certain area has certain properties on it, but you don't care about the additional properties that exist on that object or what the original type actually is. You just want to view it as this specific type. All right, so now I want to talk about enums or enumeration. Now, to illustrate why we would want to use these, let me just paste in a function example here. So let's say we have a function where we want to get the price of a specific shirt. However, the only types of shirts we can have are small, medium, or large. Well, in this case, we can actually just write the three values that we're willing to accept here for shirt size as the literal strings themselves, so small, medium, large. And then maybe we have some kind of switch statement where we're returning, $10, $20, $30, depending on the price of these shirts. Now, that's fine. You can do this. However, a problem arises when you want to change maybe small to be small. Right? Now I need to change that here as well. And then I need to change any function signatures so that they're now passing that capital S. Also, what happens if I add an additional shirt? What happens if maybe I want to use these three values in a different type of function? This is not very reusable and this is not great practice, so you probably don't want to do something like this. Instead, you'd want to create an enum. So what I can do here is say enum shirt size is equal to, or not equal to, just have my parentheses like this. And then I can say small is equal to small, medium is equal to medium, and large is equal to large. And now, rather than using small, medium, and large here, I'm simply going to specify that I'm accepting a shirt size, which now means I'm going to have one of these three values. Now, for my cases, I say shirt size dot small, shirt size dot medium, and shirt size dot large. There you go. I've just refactored this code. So now, first of all, it's a little bit more clear what the type actually is. And if I go and change any of my string values here, like maybe now I want them to be lowercase or I want to add an additional size, I can do that and I'm not breaking anything inside of this code. Now, if I wanted to actually use this function, what I would do is something like const price, if we can type that correctly, is equal to get shirt price, and then I would pass my shirt size dot small like that. So this is just a better practice, a better way to do things. I'm sure many of you have seen enums before. These are very useful. And a lot of times I like to actually store a bunch of strings inside of my enums. You, of course, can even store something like 1, 2, 3. You can do whatever you want. But this allows you, again, to now use this type in multiple different places. Rather than writing in literal values, which I don't like to be doing unless I have to, I'm now using my enumerated value. And then again, it's kind of more reusable and flexible. Hopefully you guys can see the benefit of enums. Now, let's move on. All right, so now I just want to spend a minute discussing what happens if you do actually want to have some kind of function or block of code where you're accepting different types. So in this case, I have an animal that could be a fish or a dog. Let's say this is the intended behavior. I actually want to do that. And if it's a fish, I want to call this swim function. If it's a dog, then I want to call this bark function. Well, obviously, I can't just come here and go animal.bark because bark is not a property that's shared between both the fish and the dog type. Same with swim. I'm going to get an error if I do that. Now, to get around this, what I could do is say animal as fish dot swim, and this doesn't give me kind of a problem or a red squiggly, but this is going to raise a runtime exception if instead of passing a fish, I were to pass a dog to this function. So before I can run this code with confidence that's actually going to work, I need to check what the type of this variable is. Now, unfortunately, I can't just use the type of operator that I would normally use. That's because our custom types here don't really allow us to use type of. Now, I'll show you what I mean if I try to say if the type of animal is equal to fish, which might be what you try. You'll notice that this doesn't work. It says this condition will always return false since the types string, number, big int, etc. Have no overlap. So when I check the type of one of my variables here, it's only going to return one of these possible values. In our case, it's going to be an object. It's not going to return what the name of the type is that we typed it as using TypeScript. That was a lot of types in one sentence. Anyways, how do we get around this? Well, what we actually need to do is create our own custom type check or type guard. So what I'm going to do is create a function here called isFish. Now for isFish, I'm going to take an animal, and this animal again could be a fish or a dog. And then I'm going to return from this function that animal is, if we can type this correctly, fish, and then I'm going to have an arrow function. I need to return this. Now, what I'm essentially saying when I write animal is fish is that I'm returning if the parameter animal is of type fish. So that's what this type annotation means when I write that. Now inside of here, for me to actually check that, I need to make sure that a fish has this swim method on it. So to do that, I'm going to return my animal as a fish dot swim does not equal undefined. When I do that, notice everything is fine because what I'm doing is I'm first converting my animal to the type fish. I'm trying to access the swim property. And if that's not undefined, that means all is good. I can go ahead and I can return my fish, or I can return true that this is a fish. If swim is undefined, then I'm going to return false, and that would mean that I had a dog. Hopefully this makes a little bit of sense. I know it's kind of complicated, but this is known as a custom guard or a type guard. And now we can use this isFish function inside of here to ensure that when we call the fish.swim method, it's going to be valid and not give us a runtime exception. So I can now say if is fish and this is animal, Then I can say animal.swim like that. Otherwise, I can say animal.bark. And notice that now bark is going to work because if it's not a fish, then it must be a dog. So it's able to kind of imply that using this if-else check statement that I've done here. Now my function is valid. Just wanted to show you that because sometimes you will need to write this kind of code. All right, so that is about to wrap up this video. The very last thing I want to show you is how you ignore type checking for specific lines. Sometimes it can be very complicated to actually type annotate something, or you're bringing something in from a library and you just want to ignore the kind of squiggly line that you're getting or the problem that's occurring. So let's do a very simple example where we have something like const, or we say something like let x number equal 3, and then we say, or sorry, equal 2, and then x is equal to hello. Let's say that we just want to ignore this problem. For some reason, we do actually want to do this. Well, what I can do is go // @ts -ignore, and I put that right above this line, and that's going to ignore what's on the next line so that I no longer get this compiler error, or this, what do you call it, linter error. There's all kinds of other kind of comments you can do here that will ignore specific types of problems, so you're not just ignoring the entire line. But I just wanted to show you this shortcut because sometimes it can be useful. Obviously, don't overuse it. You shouldn't have to use this, but sometimes it is necessary. So that's why I wanted to throw it out here. Anyways, with that said, I think I'm going to wrap up the video here. This was meant to be a quick overview of TypeScript. I think I got a little bit carried away showing you a ton of different features. Obviously, I want to be thorough. I want to make sure you guys have enough knowledge to actually be able to use this effectively. So if you appreciated the video, make sure to leave a like, subscribe to the channel, and I will see you in the next one.